Raoults law. Objective: to describe and understand the Raoults law. In a solution of two miscible liquids, the partial vapor pressure of each liquid is less than the respective vapor pressures of the pure liquids. The change in the vapor pressures is because of the decrease in the surface area of the liquid from which fewer molecules enter the vapor phase. In 1886, a French chemist, M. Raoult, established a quantitative relationship between the mole fraction of a component and the partial pressure exerted by it. The law states that the partial vapor pressure of each component in a solution is directly proportional to the mole fraction of it in the solution. Consider a solution with two components, 1 and 2. Let P1 and P2 be the partial pressures exerted by the components 1 and 2 respectively at a certain temperature. According to Raoult's law, P1 is proportional to x1 or P1 is equal to P1 naught x1. Here, P1 naught is the constant of proportionality and represents the vapor pressure of pure component 1 at the same temperature. Likewise, for component 2, P2 is equal to P2 naught x2. P2 naught represents the vapor pressure of pure component 2. On applying Dalton's law of partial pressures, the total vapor pressure of the mixture will be equal to the sum of the individual partial pressures of the components 1 and 2. That is, P total is equal to P1 naught x1 plus P2 naught x2. Further, for a binary solution, the sum of the mole fractions x1 and x2 is equal to 1. We can write x1 equal to 1 minus x2. On substitution this value in equation 1, we get equation 2. From equation 2, we can observe that P total is a linear function of mole fraction x2, as P1 naught and P2 naught are constants at a particular temperature. This means that the plot of partial vapor pressure versus mole fractions x1 and x2 should be a straight line. If a graph is plotted for the partial vapor pressure of the first component against a mole fraction corresponding to the equation P1 is equal to P1 naught x1, we get a straight line as shown here. From the graph, it is clear that when the mole fraction of the first component becomes 1, the partial pressure of component 1 is the vapor pressure of the pure component 1. Similarly, for component 2, we get a straight line corresponding to the equation P2 is equal to P2 naught x2. From the curve, it is clear that the vapor pressure of the pure component 2 is higher than that of the pure component 1. This shows that the component 2 is more volatile than component 1. The total vapor pressure of the binary solution P total is given by the sum of the partial pressures P1 and P2 and is represented by a straight line. Composition of vapor phase solution. In a binary solution, the vapor phase is in equilibrium with the solution phase. Therefore, the composition in the vapor phase can be determined by the partial pressures of the components. If Y1 and Y2 are the mole fractions of the components 1 and 2 respectively in the vapor phase, and Pt is the total pressure, then P1 is equal to Y1 into P total. P2 is equal to Y2 into P total. Let's summarize. Raoults law states that the partial vapor pressure of each component in a solution is directly proportional to the mole fraction of it in the solution. According to Raoults law, P1 is equal to P1 naught x1. P2 is equal to P2 naught x1. The plot between mole fraction and partial vapor pressures of the components is a straight line.